What is nuclear noise? Listen. Hello everybody, good day, you're welcome to today's tutorial. Today we're going to look at atomic number, described as Z, and mass number, which is written as or denoted as A. In our fundamental class on atomic structure, we discuss atom, elements, and other things associated with atom. But today we're going to look at atomic number, what is meant by atomic number, and what is meant by mass number. If you didn't watch or if you have not watched the first video on fundamentals of atoms, atomic structure, part 1, please kindly subscribe to that video so that you can follow what we're going to do now. Atomic number, if S represents the symbol of an element, there are two numbers always associated with the symbols of an element. These numbers are written as A and Z. A, which is the superscript, is called the mass number of the atom, while Z, which is the subscript, is called the atomic number of the element. For instance, if you have oxygen, O, now oxygen represents the atom of oxygen, that represents S in this case. We can have 16 and 8. This 16 is the mass number, whereas 8 is the atomic number. Now, somebody can also write oxygen in this form, 8 and 16. The question is this: will 8 still remain the atomic number, or will 8 change to the mass number? No. The mass number will still remain 16, the atomic number will remain 8. So how do we know the mass number? How then do we know the atomic number? The mass number of every atom is usually greater than the atomic number. So when you have two numbers on an atom, whether the small number is the superscript or the bigger number is the subscript, or vice versa, the mass number remains the bigger number, while the atomic number remains the smaller number. Another instance is phosphorus, which are written as 3115 or 1531. The mass number being the bigger value remains 31, while the atomic number being the smaller value remains 15. So what have we learned? When you have a symbol of an atom, two numbers are associated with this symbol: the mass number and atomic number. The mass number is the bigger value, while the atomic number is the smaller value. Whether it is placed as a superscript or subscript, the mass number remains the bigger value, while the atomic number remains the smaller value. Okay? Now, we are going to, before we continue, the question is, does mass number have another name? Yes. Mass number is also called, in chemistry, is also called atomic mass. Atomic mass. Or you can still call it nucleon number. So why is mass number called the nucleon number or atomic mass? Mass number in chemistry is defined as the sum of the protons and neutrons in the nucleus of an atom. So the mass number is the sum of two things: the protons and neutrons present in the nucleus of an atom. That means we can write the mass number A to be equal to number of protons plus number of neutrons. So that is mass number for us. So mass number refers to the nucleus composition of the atom. Then what of atomic number? Atomic number is defined as the number of protons in the nucleus of an atom. So we can say that atomic number represented as Z is equal to MP, where MP denotes number of protons. So little wonder why the mass number is always bigger than the atomic number. The atomic number refers to one item, which is the protons, while the mass number is the sum of two items, which is protons and neutrons. Having done that, is there any other way chemists define atomic number? Yes. Apart from saying that atomic number is the number of protons, we can still say that atomic number of an element is the number of electrons in the shells or orbits of a neutral or uncharged atom. So this is another way of defining atomic number. The number of electrons in the shells, or known as orbits, of a neutral atom. So we can still say that atomic number by formula begins as Ne. Now let's look at these two formulas. Z equal to MP and Z equal to Ne. The second definition for atomic number has a condition. The condition for this to hold is the atom must be neutral or uncharged. But this is a conclusive definition of atomic number, the number of protons. This one is a conditional definition, provided the atom is a neutral atom. Now, what do we understand by a neutral atom? Let's look at oxygen, 16.8. Let's look at another oxygen, 16.8.2 minus. These are particles of oxygen. This is the atom, while this one is charged, which we call an ion. A negative ion is called anion in chemistry. Now, looking at this, for this particular example, the atomic number is equal to number of protons equal to number of electrons. So here, the number is 8, proton is 8, electron is also 8. Now, in this situation now, the atomic number is also 8, is equal to number of protons, but not equal to the electron because the atom is charged. If it's charged, we call it an ion. So in this situation now, the atomic number is 8, proton is 8, but electron is not 8. Electron now is 10 because it has gained 2 electrons. So when an atom has negative charge, it implies that it has gained 2 electrons. I now have 10 electrons. So this is going to give you 8 plus 2. The electrons for this particle is now 10. Negative charge. Now, question is this. How do you find the charge of an ion? This is an ion. The charge an ion bears is nothing but number of protons minus number of electrons. That what determines the charge you have on an ion. That when an atom has gained or lost electron. In this situation now, this atom has no charge because the atomic number is 8. The electron is also 8. So 8 minus 8 is 0. That means this atom has no charge, it's uncharged. But for this particular atom, the charge cannot be 0 because when it is negative charge, it means minus 2. It means that it has gained 2 electrons. You now add 2 to the atomic number, giving you 10. So for this atom, number of electron charge will now be equal to proton, which remains constant 8. Electron increase to 10. That gives you minus 2. That indicates excess of 2 electrons. So another instance is when we have this aluminium 2713, aluminium again 2713 plus. For this, the first particle here, the atom, neutral atom, the atomic number is 13, the proton is 13, the electron is also 13. All these particles are equal to each other because the atom has no charge. But this one, positive charge indicates loss of electron. So the number of electrons in this case now become the atomic number 13 minus 3, which will give you 10. While proton remains 13, atomic Z also remains 13. So you see, when an atom is charged, that means electron is either more than atomic number or less than atomic number. If the atom has negative charge, it means that the atom has gained electron. If the atom has positive charge, it means the atom has lost electron. Okay. A, the same atomic number, the same number of protons, the same number of neutrons, but they only differ in number of electrons, which that's the difference between an atom and its corresponding ion. Why would a proton and neutron remain the same? When an atom forms an ion, it has either lost or gained electrons. Electrons are found in the shells as described in our former class. Electrons are found in the shell. So electron is either lost to give you positive charge or gained to give you negative charge. So electron changes number, but the proton and neutron are found in the nucleus. So when the electron is lost, these two still remain constant. So an atom at this ion, like these two, the mass number for two of them is 27. The atomic number is 13 for each of them. The number of protons is also 13 because these two are equal. Number of neutrons, which is A minus Z, is 14 for each of them. But the electron differs. This is uncharged. Electron here is 13, while electron here is 13 minus 3, giving you 10. So let us take an exercise on this. We have this table. We have copy and complete this table on the whiteboard. We have particle. We have A, represent the mass number, Z, the atomic number, Np, number of protons, Ne, number of electrons, Nn, number of neutrons. We also have chlorine, 3517, fill up these places. Then we have oxide ion. We are given 16. We are given 8. Fill up this gap. Then we have copper 2, giving in 20. For us to go on with this, what do? We're going to is given as number of protons plus number of neutrons for all to solve this. And then number of protons is equivalent to atomic number from our initial definition. That means I can still say that A is Z plus neutron. Then for a neutral atom, proton, atomic number, electron, these three things are equal for a neutral atom. Then for a charged atom, these two are equal, but this is different. This is for an ion or charged particle. Then from here or over there, if I make number of neutrons the subject, it becomes A minus Z. That is A minus Z or A minus proton. So having done that, we can go ahead and then fill up this table. Now for this table, the atomic number here, Z, remains 17. Why? Because atomic number is always equal to number of protons based on this formula. Then electron also is 17 because if you look at the atom here has no charge. That means these three items will be equal to each other. To get the number of neutrons, neutrons is A minus Z from this formula. Mass number minus atomic number, that will give you 18 in this case. If I go to oxygen, this is oxide ion. It has negative charge. We were given the mass number 16, given the atomic number 8. Now to get the number of proton 8, so atomic number is also 8 because these two are always equal. Okay? Then number of neutrons is A minus Z, which is 16 minus atomic number, that will also give you 8. Now for this one, the electron cannot be 8 again because the atom is having a charge. Now since the atom is charged, to get the number of electrons, negative charge means excess electron. We now add these two to the atomic number, 8 plus 2, that will give us 10. Going to copper, the atomic number is unknown, A is unknown. Number of protons is 29. So since proton is 29, and this atom has a charge, the electron cannot be 29. Positive charge means electron is deficient. So we subtract 29 from 2 protons, that gives you 27 electrons in this case now. Then these two are always equal. Atomic number is equal to the number of protons. So atomic number is 29. To get the mass number is what is it? Z plus neutron. Atomic number plus 29. Neutron is 35. 29 plus 35, that gives us 64. So if you look at the working, you see that everything is clear. To be able to fill up this table, we have to recognize two things. That if the atom is neutral, these three items, two number, proton, electron, should be equal to each other. And neutron is always mass number minus atomic number. We have that. If the atom is charged, the electron will change. Negative charge implies gain of electrons. So when we see minus 2, you don't subtract it. You add 2 electrons to the atomic number. That gives you 10. When you see plus, electron is also different. But this one means electron is deficient. You subtract 2 from the atomic number, that gives you 27. So this is how to find the atomic number of a neutral atom and of ions. The atomic number, the mass number. So you see that in this case now, this is an ion. The atomic number, the proton, remain constant. What defines is electron. Likewise, this one is charged ion. But for this one that is uncharged, these three things, atomic number, proton, electron will always remain the same for every atom. So, having done that, we are going to look at isotopes. Isotopes.